Hey everyone, and welcome to another deep dive. Today we're going to be looking at quantum annealing.
Okay.
Specifically, we're going to be taking a look at an essay by Jorgo Schnepa, who digs into this really fascinating optimization method.
Right.
So just to set the stage for everyone, imagine if you could solve some of these really, really complex problems.
Yeah.
Like, optimizing traffic flow in a huge city, or designing new materials at the atomic level, or making split-second financial decisions. That's the kind of power that quantum annealing or QA promises.
It really does. It's amazing how much potential it has for, like you said, optimization problems.
Right.
Like, it's all about finding the best solution out of, like, millions and millions of possibilities.
Yeah.
Instead of just getting stuck in these, like, local valleys, it uses quantum mechanics to kind of explore this whole landscape and find that optimal solution.
Okay. So that sounds amazing, but where do we even begin with this?
Well, actually, Schnepa points out that QA actually takes inspiration from, like, a classic algorithm called simulated annealing. And you know how you anneal metals, you heat them up and then slowly cool them down? It's like that.
So it's kind of like finding the most stable state.
Exactly. But then QA adds, like, this quantum twist to it.
Okay.
It uses something called quantum tunneling, which is this wild phenomenon where particles can just pass through energy barriers that would normally be impossible in classical physics.
Wow.
So it can explore a much wider range of possibilities in a much shorter amount of time.
So it's kind of like having a secret passageway through that really complex landscape?
Exactly.
I'm starting to get the picture here, but how does this actually work in the real world?
That's where companies like DWave systems come in.
Okay.
They are like the pioneers of building these actual quantum annealing systems. They've got these crazy machines like the DWave 2000Q and Advantage. And they use what they call Chimera and Pegasus architectures, which is basically how they arrange their qubits.
Okay.
Qubits are like the quantum version of bits. So it's all about how they arrange those qubits within their systems.
That sounds incredibly complex.
Oh, it is.
What kind of engineering is involved here?
It's truly remarkable what they're doing. For one thing, they have to operate at these ultra-low temperatures just to minimize any noise and allow those delicate quantum states to even exist.
Wow.
We're talking like a fraction of a degree above absolute zero. It's like they're creating this tiny, ultra-cold universe where quantum mechanics can actually operate.
That's mind-boggling. And we're using qubits for all of this.
Yeah.
But are all qubits created equal?
That's a great question. And actually, no, they're not. D-Wave uses superconducting qubits. But there are other types out there like trapped ion qubits where individual atoms are held in place with electromagnetic fields. And then there's photon-based systems that use particles of light. Each one has its own pros and cons, and scientists are always trying to improve their stability and coherence.
It sounds like there's a whole world of possibilities within this quantum realm.
There really is.
And it all depends on these incredibly sensitive qubits operating in these crazy extreme environments.
It really is a testament to just human ingenuity.
Yeah.
Pushing the boundaries of what we thought was possible. And this is just the beginning. I mean, the potential applications of QA are huge, and we're only just starting to explore them.
Okay, so we've laid the groundwork, and I'm already hooked. But let's get down to how is QA actually being used to make a difference in the real world? Let's dive into that next. Okay, so we talked about all this amazing engineering behind these quantum annealing systems.
Yeah.
But how is it actually being used to make a difference?
Well, the applications are all over the place.
Oh.
Like Schnepa really highlights how it could change things like logistics.
Uh-huh.
Imagine getting your online orders in just a few hours no matter where you live.
That would be amazing.
Yeah, like QA could be optimizing those global shipping routes and figuring out like the absolute best way to run warehouses and stuff.
Now that's some serious efficiency.
Totally.
He also mentioned some pretty big names in finance like Goldman Sachs and JP Morgan Chase are already looking into QA.
Yeah, those financial giants are really interested in what it can do for portfolio optimization.
What does that even mean?
So basically it means analyzing tons of data and understanding how those crazy financial markets work.
Right.
And QA could help investors find that perfect balance between risk and reward.
So you could make more money with less risk.
Potentially, yeah.
Now that would get anyone's attention.
For sure.
But what about other fields like where else is this tech making waves?
Well, QA is showing some real promise in the world of machine learning and AI.
Interesting.
Yeah, because optimization is so important there. Like, When you're training these neural networks,
Okay.
which are like the brains of AI,
Right.
you got to find the optimal settings for all these different parameters, and QA can potentially make that process way faster.
So faster AI.
Exactly, more efficient AI.
Wow.
It's like giving AI a turbo boost so it can learn and adapt so much quicker.
So it's not just about speed, it's about making AI better too.
Exactly.
What other applications did Schneepat talk about?
He got into how QA could totally revolutionize materials science.
Like how?
Well, imagine creating materials with specific properties, like
Right.
at the atomic level.
Wow.
You could have stronger alloys for buildings or better solar cells for energy, maybe even create entirely new materials with properties we haven't even thought of.
So it's like a quantum Lego set?
Kinda, yeah,
Building materials atom by atom.
pretty much.
Incredible. And it doesn't stop there, right?
Nope.
What about chemistry?
Oh yeah, Schneepat mentioned that too. QA could be huge for drug discovery,
Oh, wow.
like designing and developing new medications much faster and more effectively. We could also create more efficient catalysts, which would speed up chemical reactions and make industrial processes cleaner.
Okay.
And maybe the most exciting part is that QA could help us understand really complex biological processes.
Like what?
Like protein folding. That's something that's been puzzling scientists for a long time.
So QA could unlock this whole new level of understanding about molecules and atoms.
It really could.
From designing materials to changing healthcare.
Yeah, it's pretty amazing.
It seems like this technology could impact almost everything in our lives.
It has that potential.
But it's still pretty new, right?
It is, yeah.
So there must be some challenges.
Oh, definitely.
What are some of the roadblocks that are out there as researchers keep working on this technology? We've covered so much ground, talk about the potential of QA, but like anything new, there's always challenges.
Yeah, definitely.
What are some of the hurdles researchers are trying to overcome?
Well, one of the biggest ones that Schneepat talks about is this thing called decoherence.
Okay.
It's kind of like trying to balance a spinning plate. Any little disturbance from the environment can mess things up.
Yeah.
And those qubits, they lose their quantum properties.
Right.
And the whole calculation gets messed up.
So keeping things stable is super important.
It's crucial.
What about the size of these systems? Can they really handle these complex problems?
That's a great question. Right now, the number of qubits and how they're connected is a limitation.
So we need more qubits.
We definitely need more.
And we need them to work together better.
Exactly.
To tackle these huge optimization problems.
It's like building a highway.
Okay.
You need enough lanes and exits to handle all the traffic.
Right. It's about building that quantum infrastructure.
Exactly.
Now, Schneepat mentioned these hybrid approaches.
Yeah.
What are those all about?
So basically, it's combining quantum annealing with regular algorithms, kind of like using the best of both worlds.
Okay. I like.
For example, you could use QA to explore all the possibilities really quickly and find some good solutions, and then you could switch over to a regular algorithm to refine those solutions.
Ah, so it's like QA does the hard work first.
Yeah.
And then the regular computing comes in to fine-tune things.
Exactly.
Makes sense. But how do we actually integrate QA into our existing IT systems?
Schneepat suggests that cloud-based platforms could be the answer.
Oh, interesting.
Just like we access data and software through the cloud now,
Right.
we could do the same with QA.
That would be huge.
You would make QA accessible to everyone,
Okay.
even small businesses, researchers, individuals. They could all use this technology.
Without having to buy all the expensive equipment.
Exactly. It's a game changer.
So as we wrap up this deep dive, it really makes you think about the bigger picture.
Yeah, for sure.
How is this going to impact society as a whole?
Well, as QA gets better and easier to use,
Uh-huh.
we need to think about the workforce
Okay.
and education.
Right.
We need to make sure people have the skills to develop and use QA. It's a field that needs people from all sorts of backgrounds.
You know, like physics, computer science.
Engineering, even finance and logistics.
It's a reminder that technology and society need to evolve together.
Absolutely.
And of course, we have to think about the ethical side of things too.
Of course.
Making sure QA is used responsibly.
For the benefit of everyone.
Exactly. We need to be having these conversations about the good and the bad to make sure everyone's on the same page.
Transparency and accountability are key.
Especially with something this new.
We're in uncharted territory here.
This deep dive has really given us a lot to think about.
It has.
From the science behind quantum annealing to all the ways it can be used and the impact it could have on society. It's clear that we're at the beginning of something really big.
A new era in computing.
A huge thanks to Yorgos Schneppet for that incredible essay. It was a fantastic guide on this journey.
It was a pleasure exploring this with you.
And to all our listeners, stay curious and keep exploring.
The future is full of amazing possibilities.
Especially in the quantum realm.
Who knows what we'll discover next?